Let's look at some more details associated with graphing trig functions. Over here I've drawn the graph of y equals sine x right here. And I want to take a look and see what the graph of y equal 2 sine x looks like. And I'm going to make a little table here of values between 0 and 2 pi in multiples of pi over 2. Well, so if I put 0 in for x, the sine of 0 is 0. I know that. I can see it right here on the graph. 2 times 0 is 0, so I end up with just 0 for y. So this graph, y equal 2 sine x, is going to go through this point on the x-axis. When I put in pi over 2 for x, the sine of pi over 2 is 1. I can see that from this graph right here. So the sine of pi over 2 is 1 times 2 is going to give me 2. So when x is pi over 2, this blue graph is going to be up here at 2. Now when I put in pi again for the sine, I get 0. 2 times 0 is going to be 0. So I'm back down here. I put in 3 pi over 2 for x, and the sine of 3 pi over 2 is negative 1. Negative 1 times 2 is going to be negative 2. And then when I put in 2 pi, I get 0 for sine x. 2 times 0 is 0 again. So you can see that the blue graph is going to drop down here to negative 2 and then come back up to 0. So if I sketch the graph of that, I'm going to get this. Okay, so you can see what happens with this 2 right here. It changes the amplitude of the graph. It doesn't affect the period at all, but it changes the amplitude. How about y equal negative 4 sine x? Well, if putting a 2 in front changes the amplitude, doubles the amplitude, putting a 4 in front is going to make it 4 times as big. So if I just looked at 4 sine x, I know my graph would go up to 4, down to 0, down to negative 4, and back up. But in this case, I multiplied all of those y values by this negative 1 right here, negative 1 times 4 or negative 4, either way you want to look at it. That negative sign changes all those y values to their opposite. So instead of starting here at 0 and going up to 4, it's going to start here at 0 and go down to negative 4, back up to 0. Over here it's going to go back up to 4 and then down to 0. So that graph is going to look like this. Its amplitude is 4 and it's reflected about the x-axis. Okay, I want to play an old tape I did a number of years ago that has to do with this same thing. Has a little graphing calculator things in there. It's the old TI-82, so you don't see those too much anymore, but the idea is the same. So watch this tape.
In this section we want to look at the kind of equations that change the amplitude and the period for the basic graphs that we looked at in the previous section. So what I've written over here is this: y equal a sine bx and y equal a cosine bx will have graphs that have amplitudes equal to the absolute value of a and periods equal to 2 pi divided by this number b. Now I'm going to assume right here that this number b is a positive number. A can be either positive or negative, and I just want to look at the absolute value of it, and that will tell me what the amplitude of the basic sine curve changes to, or the amplitude of the basic cosine curve changes to. What I want to do first is go to the graphing calculator and explain this in terms of some actual coefficients. Let's go to the graphing calculator now. Let me show you first of all what I have for y variables right here. My y1 is going to be my basic sine x curve. y1 is equal to sine x. For y2 I've changed this coefficient. It'll be 2 sine x, y3 is 3 sine x, and y4 is 1/2 sine x. So according to what I was saying previously, these numbers in front should give me a new amplitude for these graphs. I'll show you the window here. Goes from about negative 360 to positive 360 in increments of 90 along the x-axis, and y goes from negative 4 to 4. Here's the graphs. First of all, y is equal to sine x. Here's my basic sine curve. Y equal 2 sine x. You see it goes up to 2 and down to negative 2, but has the same period. There's y equal 3 sine x. Again, same period, but now an amplitude of 3. And here comes y equal 1/2 sine x. So you can see that that has an amplitude half of the previous amplitude. Next, what I want to do is go back and change another coefficient. This time let's look at the y, go back to my y variables, and I'm going to change this to y equals sine of, let me move over here, 2x. And then I'll go down to my next one, I'll delete that coefficient, and I'm going to change this to y equal the sine of 3x. And then I'll go down again and delete this coefficient. And did I get it all? No. And then go over here and graph y equals 1/2 sine of 1/2 x. I'm going to change my window to go from x equal 0 to x equal about 4 times, let's see, I want to go, how about x equal 720 degrees. That'll be twice 360. And let's change, I want to go down and change my amplitude or my y values from, go from -2 up to +2. Okay, let's look at these graphs. Y equals sine x. You see it goes through 2 complete cycles between 0 and 4 pi. There's y equal 2 sine x, y equal 3 sine x, and then y equal 1 sine of 1/2 x. So you see y equals sine 1/2 x goes through 1 complete cycle between 0 and 720, or between 0 and 4 pi. Let's go back and look at our y variables list. This coefficient in front of x right here tells us the number of complete cycles that the curve will go through between 0 and 2 pi. So on this graphing calculator, we see that this coefficient right here of x tells us the number of complete cycles that the graph of y equals sine x will go through between 0 and 2 pi, or 0 and 360 degrees on the x-axis. Let's graph this one by hand. According to what I've wrote before and what I confirmed using the graphing calculator, this coefficient is 1, so this graph will have an amplitude of 1, and the period will be equal to 2 pi divided by 2, which is pi. So if this curve went through 2 complete cycles between 0 and 2 pi, then it goes through 1 complete cycle in pi units on the x-axis. So I'm going to label this with pi. Here I'll label this with pi over 2. This 1/4 of the way will be pi over 4, and right here will be 3 pi over 4. The amplitude is 1, so I'm just going to have my curve go up to 1, down to -1. It's a basic sine curve, so it starts at 0, goes up to 1, back down to 0, down to -1, and back up to 1. So this is 1 complete cycle of y equal sine 2x. The amplitude is 1, and the period is pi. So if I was to extend this to 2 pi, you see it would go through 1 more complete cycle, and there I would have 2 complete cycles between 0 and 2 pi on the x-axis. So that coefficient tells you the number of complete cycles the curve goes through in what was 1 period of 2 pi for the basic graph. So to find the period of the new function, we just take the old period 2 pi, that is the period of the basic sine curve, and divide by that coefficient 2. That gives us pi. Let's try another example. This time we have y is equal to 1/3 sine x. So that leading coefficient, or the coefficient in front of sine x, is 1/3. So that means my amplitude will be equal to 1/3. And my period will be equal to 2 pi divided by this coefficient, which is 1. So I just end up with the normal period of y equal of 2 pi units on the x-axis. So let's label this point 2 pi. Halfway between those two will be pi. Halfway between those two will be pi over 2, and between here and here, this should be 3 pi over 2. The curve will go up to 1/3 and down to -1/3. It's a sine graph, so it starts at 0, goes up to 1, or I should say 1/3 at the quarter point. At the halfway point, it's back down to 0. 3/4 of the way through the cycle, it'll be at -1/3, and then when I come to the end of the cycle, I'll be back to 0. So here is a nice, quick, accurate sketch of 1 complete cycle of the graph of y equal 1/3 x. So this coefficient right here changes the amplitude. This coefficient over here changes the period. Here's our next example. This time I have a cosine curve. My coefficient a is 1/2, so I'm going to have an amplitude of the absolute value of 1/2, which is 1/2, and I'll have a period of 2 pi divided by 3. So 2 pi over 3 for the period. So let me mark the x-axis, or first let's mark the y-axis. The amplitude is 1/2, so it'll go up to 1/2, down to -1/2. The period is 2 pi, so I'll just put, 2 pi over 3, so I'll put 2 pi over 3 right there. Halfway between 0 and 2 pi over 3 will be pi over 3, and then halfway between here and here, between 0 and pi over 3, will be pi over 6. So what I have is 1 pi over 6, 2 pi over 6, this will be 3 pi over 6, and then 4 pi over 6, which reduces down to 2 pi over 3. So 1, 2, 3 pi over 6 will be reduced down to pi over 2. Now it's a cosine curve this time, so it starts up at 1/2. A quarter of the way through the cycle, it's down to 0. Halfway through the cycle, it goes down to -1/2. 3/4 of the way back up to 0, and at the end of the cycle, it's back up to 1/2. So here's a nice accurate sketch of one complete cycle of the graph of y equal 1/2 sine 3x. It'll have an amplitude of 1/2, a period of 2 pi divided by 3, and it's a basic cosine shape. Let's look at our next example. Y is equal to 2 sine pi x, so this will have an amplitude. Whoops, can't spell amplitude. Let's abbreviate it, AMP, equal to the absolute value of that coefficient, so that will be 2. The period this time is going to be 2 pi divided by this coefficient, which is pi, and so that ends up to be just 2. So an amplitude of 2 and a period of 2. So I'm going to mark on the x-axis then. It'd be nice I could actually probably do these equally spaced, but I won't. On the x-axis, that'll be 2. Halfway is 1. Halfway there is 1/2, and right here, 3/2. The graph goes up to 2 and down to -2. It's a basic sine curve, so it starts at 0. A quarter of the way through the cycle, it's up to 2. Halfway through, it's back down to 0. 3/4 of the way, it's down to -2. And at the end of the cycle, it's back to 0. A nice, accurate sketch of y is equal to 2 sine pi x. So this coefficient here doesn't have to be an integer. It could be an irrational number like pi. In that case, the new period is going to be 2 pi divided by this coefficient here, pi, so I end up with a period of 2. Now I could have had equally spaced units on the x-axis and the y-axis so you could get a real good picture of what this looked like. This would be a good one to try on the graphing calculator and then use the trace button and see if we get at x equal 1/2, y is equal to 2, at x equal 3/2, y is equal to -2. If you do that, of course, you will get that on the graphing calculator.
Okay, so you can tell that video was shot a few years ago. I want to continue that last problem though and just extend the range over which we graph that function. So here we have y equal 2 sine pi x between 0 and 2. That's the graph that we just saw right there. Let's extend that so we get y equal 2 sine pi x between -4 and 4. Well, we can tell one period is 2 on the x-axis, so if I want to go out to 4, I'm just going to repeat this graph again. So let's do that. So there it goes out to 4. Now let's go the other way and have it go from 0 to -4. Well, it's going to come back down here like this, come back up there, up and back down. I can't draw too well this way, but I'll give it a shot. And then back down again, up, and then back down. So there's what the graph looks like between -4 and 4, and you can see I've got one cycle here. Here's another one. That's 2 cycles, 3 cycles, 4 cycles. So between -4 and 4, this graph goes through 4 complete cycles. Let's work a couple more problems. Okay, first we want to graph this equation, y equals sine pi over 2x. Well, I can look at this and see that there's a coefficient of 1 there, so my amplitude will be equal to 1. My period will be 2 pi divided by pi over 2. So 2 pi divided by pi over 2, let's see, that's going to be the same as 2 pi times 2 over pi. When instead of dividing by pi over 2, I multiply by its reciprocal, 2 over pi. Those numbers divide out and I end up with 4. So for this graph, I know I'm going to have a period of 4. It's going to have an amplitude of 1 and it's a sine curve. So I can fill in the x-axis here. I'll go through one complete cycle in 4 units. That's 4, that must be 2, there's 3, and 1. Okay, let's draw a sine curve that does that. Start here at 0. At 1, it'll be 1. At 2, it'll be back down to 0. At 3, it'll be -1. And at 4, it'll be back up to 0. Connect those with a nice smooth curve, and I've got the graph of one complete cycle of this equation. So it should look something like this. Not too bad. Okay, Now here I have a graph, and what I want to do here is just from the graph identify the amplitude and period. So first of all, I notice that this graph goes up to 3 and back down to -3. So I know just by looking here that the amplitude for that graph is going to be 3. Now what's the period going to be? Well, the period is what it takes on the x-axis for that graph to go through one complete cycle. Well, let's see, here is one complete cycle. That seems to repeat itself again and again, and that happens between 0 and pi. So the period for this graph must be pi. Okay, so that's a look at graphing trig functions in relation to their amplitude, their period, and some reflections.